we are given this, and the solution process is this. So that's a concept, the node. And now I want to talk about the concept in solving these questions. And this one, how can we do that one? And what kind of information we can use? From the previous chapters, and through the linear combinations of f and f dot g dot, we know that for any, say, for example, if, say, this is the R1 here, and this is R2 here, so we can, say, treat it R1, this is V1, and we can treat V2. This is the initial point, and that is the derived point. So basically here we can say R1, R2 equal to the linear combinations of the R1 and R2. So that is R1 and plus V1, and R1 plus V1. And we know the linear combination is through these coefficients, F, G, and F dot, G dot, right? So that is from our previous the concept here. So now for this case, we are given R1, R2, and we want to find the V1, V2. So from here, you can see basically V2 appear here. So basically here, from this equation, that can give us the information about the V2. Okay, so assuming V1 is known, then basically V2 can be calculated by this. So basically the whole thing is depends on how we determine the V1. Okay, so the V1 is, let me write it out, the Fg first. So F here, and equal to 1 minus R2, and divided by P, 1 minus cosine theta nu, and G equal to mu P. The reason why I want to rewrite this one because I want to show you some relations. Okay, and on the other side, we also have expressions is this in terms of the eccentric anomaly. And V1, here we have, let me rewrite here. So based upon the two equations, V2 equal to this one, we know. And from this equation is V1 simply equal to R2 minus FR1 and divided by G. Okay, so let me rewrite V2 again. That's trivial. Okay, so basically this is our destination. That is the goal we want to achieve. We can determine V1 and V2. Basically, get this V1, you simply remove this term to that side, divided by G. So we will determine V1, V2 through the two expressions. And how do we determine this one? And as long as we solve for V1, then we can solve for V2. As long as we know the value of Fg, then we basically the whole things will become about. So the whole solution process is hinged to how to determine Fg, F dot, G dot based upon the given information. Okay, so here I give the logic thinking about this. And so given these things, we can say how to do the things. So we think about this one. The first one you need to determine, you're going to take the short way or long way. Okay, and once you determine the short way or long way, so that means here the true anomaly data mu is given. So here from this given information, I want to get more precise information. So determine once we have determine the short way or long way. So this one, basically here we know the angles between the two vectors we know. So here let me edit up the additional informations. Okay. And from here, once we know this one, and once we determine the orbits, basically the t, time of flight can be determined. Because here we can, once we know the data mu, then using Kepler's equations, we could determine the time of flight. So assume that t is given here. So from here you can see we have 7. In those equations right now, we're going to focusing on to solve for the 4 the combination coefficients. In those equations, you're going to see. Throughout those equations, we see we can go through one by one to label the variables we have. So in the 4 equations and how many variables we have. And we have the R1, we have R2, and we have data nu, and we have P, we know the P, we know the A, and we have data E. Okay. So basically here I just go through the nothing more, nothing less. If you go this carefully, we have 7 variables. And for the 7 variables, we know how many we know. And we know R1, and we know R2, and we know the data mu. And for example, say assume the time of flight, you know, we have 4 given informations. Okay, so from these equations, and also here in this way, you can see we have 3 out of the 7 variables, we have 4 unknowns. So but basically here we have 3 unknowns to be solved. Right. And also from the 4 equations, we know that we have a relation is 1 equal to f g dot minus f dot g. So basically, with this constraint combined, 1, 2, 3, 4 coefficients basically only provide us 3 independent equations. Out of the 3 independent equations, we have 3 unknowns to solve. So in theory, three equations, three unknowns, we should be able to solve for it. Okay, so now the issue is how to solve for this one. The three unknowns basically is right now we know this, we know this, we know this, we know this. So basically the three unknowns is P, A, and delta E. Okay, so how to solve for P, A, and delta E? Look at those equations. Those equations are not linear, they are nonlinear, and also they are involved with the sine cosine, and also have the cube in the square root. So basically, those are the very typical examples of we call the hyperfunctions. Okay, so. We can solve for this one in theory, but in reality, how to solve for this effectively, and that's another story. So that is the first portions in these chapters. People like to pick it up. So here, let me think in the process. So the general step is this. So we guess one of the PAE. So we guess an arbitrary value here. So for example, we guess P, then we solve for A and delta E. And solve for A and delta E is through the iterations here. So we solve for the remaining two unknowns variables. And here our important strategy is we using the F and F dot. Okay? And so basically here our thinking is we guess one value, we solve for the other two unknowns within with the two equations. Okay. And then we test so I think that's the logic. So then use equation G. Use G functions to, right now we have solved for Fm dot. So assuming right now we have the three unknown variables have the value there. So right now we're simply using G function to calculate so how many T, whatever. Okay. So the T, we guess one value. So T would be, say, P or A or delta E. And then we have the two unknown to solve. And then we're going to calculate using G to calculate the corresponding value of Tn. So n. Okay, so here this is an n equal to 1. Okay, so now we have the calculated, and that is based upon then we can determine Tn with T, would that be close enough if we so lucky we've made a very good guess, then once we do the whole calculations, the whole thing must satisfy the equations. The result must be very close. If not close, then that means our guess is not good. If the guess is not good, then improve the guess. And then we go to here again. So that is the loop. Okay, so we keep changing. We make the guess and we do the calculations and we improve the guess, and then until this one, until the difference, our guess and calculated is close enough, then we stop. So pretty much from here, without the further details, and I'm going to do it Monday. So pretty much from here, you can see this is a loop. And how to improve? The improvement basically is based upon, again, there's quite a few numerical methods. And again, here in this chapter, we're going to use Newton's search method. Okay, and that is the one pretty effective. So the improvement basically here is, again, the Newton's method in terms of the numerical one. Okay. So we're going to use Newton method and to improve this one. So basically, the involve calculations, and those kind of the function will be a little bit more complicated than previous chapters. Okay, so get ready for this one, and I can tell you, you can shut it off this one.